So a ball of mass 50 grams. To use the momentum equation, we have to convert that to kilograms, so that would be 0.05 kilograms. Moving at 8 meters per second to the right, hits the wall and rebounds. That implies that it is now moving to the left after it rebounds at 6 meters per second. I have to calculate the momentum of the ball before it hits the wall, after, and then the change. So in a problem like this, signs of the velocity become very important. So I'm going to say, let right be positive. So let's begin. 10.1, calculate the momentum of the ball before it hits the wall, in other words, going to the right. So say P equals M times V, mass 0.05 times by 8, and it's positive because it's to the right, and I get 0.4 kilograms meters second to the minus 1. 10.2, calculate the momentum of the ball after it hits the wall. Again, I use my momentum equation. Same mass, 0.05 times by minus 6, because it's rebounding. We've said let right be positive, so left must be negative. So we get minus 0.3 kilograms meters second to the minus 1. So the change in momentum is P final minus P initial. Now my final momentum was minus 0.3 and my initial momentum was positive 0.4. So I get minus 0.7 kilogram meter second to the minus 1. I cannot leave the minus like that. I have to justify, I have to interpret that sign, so I actually have to say that is 0.7 kilogram meters second to the minus 1 left. Because I've got a negative and I've said let right be positive, it is left.